Educación es una oportunidad para crecer, para brillar y superarte ante la adversidad. En la UISEK somos tu segundo hogar y mantenemos la excelencia académica como la bandera que nos caracteriza, con un ambiente cálido y humano pensando en ti. Permanezcamos unidos y seamos fuertes en el camino. Cuenta con nosotros para mejorar tu futuro. Universidad Internacional SEC, personalización en serio.
Buenas tardes con toda nuestra audiencia y bienvenidos al seminario web Desafíos de llevar robots autónomos a la industria de la construcción, organizado por la Universidad SEC con nuestro invitado, el MBA Nadav Shuruk de Israel. Estaré ayudando con cualquier pregunta de la audiencia en nuestro canal, en nuestro chat en vivo en YouTube al final de la presentación. Good afternoon and welcome to the webinar, Challenges of Bringing Autonomous Robots to Construction Industries, hosted by SEC University, with our guest, the MBA Nadav Shuruk from Israel. I will be helping with any question from the audience on our live chat on YouTube at the end of the presentation. Now, Karen Garzon will help us introducing our guest.
Thank you very much, Gustavo. Nadav Shuruk has a BA in Business Administration from ADC, an MBA from the Hebrew University Executive Management Program, with a specialization in finance, financial engineering, and banking. Prior to founding OKIBI, Nadav serves as a senior consultant for corporations in the field of corporate business, project and infrastructure financing and investment banking. In 2016, Nadav started managing GG Robotics, which specializes in robotics, aromatization, and X-ray, and provides maintenance, engineering, and execution services for the defense and civilian industries. Nadav is a co-founder of OKIBI, and he founded in 2018. Thank you very much, Nadav, for being here. It's a pleasure.
Thank you. Thank you very much for this presentation, and thank you for having me. I will now share my my presentation. Yes, so hi. I'll be talking today about some challenges about bringing robots, especially autonomous robots, to the construction industry. We founded OKIBI 3 years ago with very limited knowledge about this industry. We had some knowledge about robotics and autonomous robots, but combining those two industries together, we found out it's a big challenge, and I will be happy to share with you some of those challenges within the next 20 minutes or 30 minutes that we have in this talk. So I'm not sure how construction sites looks like in Ecuador. I know how they look in Israel, something like this. Especially, you know, you see a lot of mess and debris and all sort of elements hanging around the site. In Europe, as far as I know, in other areas, the site looks a little bit better, but overall, it's not the nicest place to be. It has a lot of stuff all around. And the question is, how do you bring very sophisticated equipment combined with, you know, computer vision and cameras and all sort of computers and everything on top of it, something like this? How do you take this to this? So this is a very big challenge. And one of the challenges, luckily, that we see today that are being solved with the penetration of a lot of robotics solution to this industry, together with what we are trying to do, we definitely hope that this industry will change and will be able to adopt new technologies and all sorts of robotics that eliminate safety issues, solve the labor shortage, and also here are some examples that you can see. There are some brick lane robots that we already see in job sites. There are 3D printing machine devices that solving the shortage of homes, affordable houses. We see robots that providing rebar works with rebars and elements that doing sometimes off-site and sometimes on-site. You see all sort of small robots like the Boston Dynamics Spot walking around the site, capturing some data. So all this is very exciting. And for us, it's a big opportunity. And as I'm mentioning here additional companies that we see recently providing robots to this industry. Maybe some of them you already know, like Construction Robotics from the US and other 3D printing companies, companies who marking the job site. So all in all, we see a lot of companies that are trying to bring robots to the site. But we are still in a period of development. It's still a period of just introducing these robots to the site. And the big question is why this is happening? Why is it so difficult to bring a robot to the site? So there are several requirements for robots, and I will divide it to the basic requirements, and later on some specific requirements that are here for robots. So of course robots has to be accurate. That's of course goes without saying, because people are very accurate, and when you want to replace people or help people doing some of the tasks, you have to be accurate. Strength is something that of course you need to lift weight, you need to act in a very difficult environment, you need to do things very quick in a safe manner, and of course be prepared to all sort of things that's happening so fast, and adjust yourself to those constant changing environment. But these basic requirements are very limited. It's not everything that required from a robot that needs to be operated in a construction site. There are some additional requirements that are very unique. For example, you need mobility. You need the robot to be able to move in the construction site. And as you remember the pictures that I shared at the beginning, it's not a trivial task at all. In terms of reach, you need to reach all sort of areas in the construction site. Even if we're speaking about indoor places, so yeah, you need to reach ceilings, you need to reach floors, you need to be able to lift yourself to all sort of areas. So it's not that trivial. Maneuverability is very close to mobility, but if mobility, you need to move from one place to the other. When I say maneuverability, you need to cross all sort of obstacles in the site. So it could be ramps, it could be slopes, it could be stairs. Something that for a human being is something that very trivial. You just do it easily. But when you're bringing a heavy machine to the construction site, this is a completely different scenario. One more thing that is very important is, of course, the interface between the human and the machine. So we hear about collaborative robots from time to time. It's something that's very common in recent industrial applications, such as assembly lines and factories and so on. But when you're taking this robot into a construction site, when you interact with people, there are a lot of employees, a lot of workers going from place to place, crossing the robot area. That could be a very unsafe thing for the human beings. And of course, keep in mind that robots expected to hold all sort of tools that currently people are holding. such drills, such as knives or spatula or any other element that can perform a lot of damage when come into close contact with human beings. So this is something that's required from any robot, and of course, if you're discussing autonomous. The last two things that are required and are very, at the high end of technological breakthrough is what we call 3D mapping and localization and the autonomous operation. So at the end of the day, what we are trying to do in other companies is to bring a very sophisticated machine that will perform all sort of tasks in the construction site. But in order to operate an autonomous machine in a construction site, you need to have some sort of 3D perception that allows you to plan the movement of the robot, not pre-program it. Otherwise, it's not autonomous. But you need to apply some algorithms that will use autonomous movement on this field. Just to demonstrate some of the things that I'm talking about. For example, if you want to put a robot, in a construction site and telling it to perform a drilling task, you need to know exactly where are the points that you want to drill. So in order to do that, you need to get information about the surroundings. You need to understand the 3D map of the area. This is one challenge, and the other one is to direct the robot to reach the exact point to drill in this ceiling or in this wall. So all in all, there are a lot of requirements, and some of them are contradicting to one another. Because if, for example, you need a robot to move in the site, but you want it to reach large areas, you need a robot to be big. But if it's a big robot, you cannot transfer it in the site, for example. So all those requirements, as I mentioned, are can be very contradictory. So some applications that our company is dealing with, and I will try to combine what I presented earlier to what we're trying to do. So OKIBI is developing a robot for applying wet materials, part of the finishing process. So what we're doing basically is we take paint, we take plaster materials, we take primers, all materials that are used to cover internal walls when you finish the construction part, and we apply them autonomously with the robot. We're using all sorts of equipment like a spraying machine that usually are adopted by human beings, and transform them into robotic operation. So we're doing painting, we're doing coating, we do insulation, we perform drywall finishing. By drywall finishing, we mean to apply premix materials on drywalls and then sand it. And if in several cases, when you have like two drywalls standing one too close to each other, another, there's a joint between them that need to be covered. So all those sorts of applications are being done by our robot. So here I'm going to present you some of the challenges that are really relevant for us, for OKIBI, and later on I will present how we dealt with it and solve those solutions. Some of the things that I'm showing now are connected to the requirements that I presented earlier. So at the end of this talk, I think you will get the picture of the challenges. So one big challenge that we have is the reach. We need to reach ceilings, we need to reach the floor, and sometimes in the same room we need to cover also the lower end of the room and the highest corner. So you need to have the ability to cover all the areas of a room. This is not trivial at all. And at the beginning of the entrance to the site, you need to enter, go through doors. So the doors sets the size of the robot. So you cannot be any wider, and you cannot be any taller than a standard door. And sometimes you even need to get into bathrooms that the doors over there are much narrower. So those demands are in contradiction. Another big challenge that we have with our robot is the power, the energy. We at a very early stage, we got into the clarification that we have to have a robot that is battery operated. But it's very difficult to have a battery operated robot in a site because the power consumption is very high, because we're using devices like a robotic manipulator and a pump that is very strong. So how do you bridge this demand? Because we decided we don't want the robot to have any power cords hanging, or any pumps that are cords, that any hoses that are hanging out behind the robot, because otherwise this will affect the autonomous movement. Because if you want to have a robot that move freely in the job site, you cannot have cords hanging around it, strapped around your wheels and so on. So you have to have some battery operation with the robot. Additional challenge is all the cables and the cable management that you have around the robot. You have the electricity wires, you have the materials wires, you have all sorts of electrical cables that need to be managed and not hang around the robot. This is another challenge. Yeah. Sorry about that. Yeah. Another big challenge that we have is how to lift the robot in the site. So, the robot weighs around 500 kilograms. This is not something that you can just, take by hand and take it from one floor to the other. The projects that we aim and we wish to work, can be high rises. And how do you take the robot from the entrance to the site to the 14th floor? So the robot has to be adapted to external lifts, or can be carried away by a crane, or a tower crane, or a forklift. All those elements need to be able to lift the robot to the specific area. So this is in line with the size of the robot that I presented at the beginning, with the door limit. So we decided that the robot has to fit into a door and to an elevator. So this limitation set the size of the robot. Additional problem that we have is material. Of course, we need to process all sort of plastering and finishing materials to the robot. And sometimes materials are coming in a very different texture, like powder, like liquids, like premix materials. How do you process them into the robot? So what we've decided to do also in very early stage, that we combine a pump on top of the robot. So this is something that we think is very important. This robot is very individual, is very independent. It doesn't need to be connected to a pump that is very sets far away from the robot. It has to be something very very close. So we mounted the pump on top of the robot. This is of course added some weight and some complexity, but it's also set the materials that we will use. So for us, the current materials that we're using are only materials that comes in bucket and are liquids or premix. So we're not processing powder yet, because if you want to process powder, what called the dry mortars, you need to have water also and mix them, whether it's outside of the robot or on top of the robot. And this creates a very big challenge. And the last challenge that we're facing on a daily basis is of course the site itself, which is very dirty, and you have to have very high ground clearance of wheels and stronger motors and gears that will allow you to cross all sorts of obstacles, whether it's small slopes or stairs and so on. This is something that has to be addressed well while designing and developing the solution. Okay, so what we did in OKIBI. So we developed all sorts of technologies that we apply in our robot, and we divide it into three major pillars. So the first pillar is the robotic platform itself. So the robot, as I already described, needs to have all sorts of requirements. Here you can see in this slide our fourth model called the EG number 5. It's a model that we ran last year in some job site testing them. You can see, if this is the robot, you can see on the top end there is the robotic manipulator standing on top of a linear axis. This axis lifts the manipulator, and this what gives us the ability to move from floor to ceiling. All the movement is synchronized, so we can, keep constant velocity and constant distance from the wall, and in one motion, actually, cover a specific area in the wall. As you can see here, this is the pump, and in this case, this is paint, the blue pump. So the pump is mounted on top of the robot, and the material feeding is being done with buckets. So we take the bucket, we mix the paint. Sometimes you need to dilute it a little bit with water and mix it, and then we just mount it on top of the robot into the pump, and we have the ability to spray the robot and to spray the wall. Here you can see, in terms of our ability to maneuver and to cross all sort of obstacles in the area. You see some ground clearance, like 10 to 15 centimeters, that allows us to cross all sort of pipes around and so on. And here in this area, you can see a big cabinet. This cabinet holds all the controllers and computing system that requires to operate the robot. So this is, the platform itself. The platform is connected at the end to a spraying gun, and of course, with this we can we operate it electronically, and we can spray the materials. The second part of the core technology that we address, and this is not that it's very difficult to present. It's behind the hood. It's our ability to scan and provide a real-time image of what we see. At the beginning, if you remember, I described one of the challenges is to create a 3D model, 3D map of the construction site. So for us, it's mandatory. We have to have digital information of the room. And not all construction sites have those digital information, even though this is something that is starting to get like a standard in several countries, like in the UK, for example. But in most of the construction sites, the digital information is not available. So we have to create our own digital map, and we have to create it in real time. We cannot, use 3D scanners or SLAM or other technology that is available, because each technology has its own limitation. 3D scanners are very slow to process. They just, provide you with point cloud, and then you need to process it for a long time, and they're not calculating all kind of shadows and blockage that you have during the scanning. So it's not really effective for our use case. SLAM method is also problematic because it provides you a picture, and then you need to stitch them. And when you stitch those pictures, you have a drift, and the drift error gets bigger and bigger, and it's not very good for us because we need the accuracy of these images. So we had to develop some algorithms that provides real-time image. Luckily, we had a good We still have, of course, a very strong algorithm team that developed an algorithm that enables us with very, as you can see in this short clip, with very affordable equipment. For example, RealSense, Intel RealSense cameras, it's RGBD cameras, depth cameras, allows us to capture the walls. In this case, you see dry walls that already has some tapes on them and screws that are already covered. This was taken in our backyard in the area that we built for some training. So you can see how the robot creates its own image. And the third piece of software and technology that we're develop is our ability to create an autonomous path planner. And by creating an autonomous path planner, it means that the robot, once it creates the digital map at the previous stage, it plans its own movement. So we don't program it. Our engineers are not programming the robot each time we see a wall or a room or a floor. The robot creates its own map, and after that, it creates its own movement profile. So in this photo, for example, you can see on the floor the X's, which points the locations of the robot. The next and the next after that location the robot needs to be in order to perform the full coverage of this wall that in front of it. And in this area, you can see that the robot identified that there are some doors and a window here. So in those areas are not covered by the robotic motion, and you see the green lines here. Stands for the movement of the robotic manipulator. So the robot, once it creates its own 3D model, start to operate, and then moves from to the second point, relocate itself in this area, and then continues the movement. And once it covered the next area, it continues to the next, and so on until it finish the complete work. And actually, I think, as far as we know, we're one of the only companies, or the only companies in the world that demonstrated autonomous movement at the indoor surfaces of robotic robot with manipulator, covering 4 walls in one movement without the involvement of an operator. Let me show you a video that demonstrates this, what I said. It demonstrates the technology, and it demonstrates the application of paint, in this case, in a construction site in Israel that we did last year with the previous model. Okay, so this here you can see the robot. Here you can see for example, the camera and the spraying gun. This is the part when the robot creates its own 3D image. We have the ability to compare the image that we provide to the images of the site, and if there are some mismatches, we can direct the project manager. In this case, you can see that the robot identifies the walls and the windows and does not paint them. The robot, as you can see, is battery operated, no cords, no pumps, nothing dragged after the robot. And here you can see the robot moves from one wall to the other. Of course, it's in fast forward, but the robot moves and perform very accurate wall covering from floor to ceiling in a very synchronized manner, as I described earlier. And once you finish the area, it can be transferred by the operator to the next working area. Yeah, so this is basically, in a nutshell, what we've been done, and the difficult and the challenges of bringing robots to the construction industry. OKIBI is still in a very advanced R&D process, and we're only now about to test our first units in job sites outside of Israel. So we have some construction companies that are hosting us in Germany actually next month for some trials, and following those trials we will be able to finalize the development and bring the product to the market. And I will be happy to address your questions and let you know what we're doing in the next steps.
Thank you, Nadav, for your presentation on such a novel and interesting topic. It has been a pleasure to be part of this event. In the name of the SEC University and all the audience, I want to thank you for your time and knowledge. Gracias, Nadav, por su presentación sobre un tema tan novedoso e interesante. Ha sido un placer ser parte de este evento en nombre de la Universidad SEC y de todo el público. Quiero agradecerle por su tiempo y conocimiento. Para nosotros este es un evento muy importante en nuestra área y especialmente para nuestras carreras de ingeniería automotriz, mecánica, mecatrónica y nuestra nueva carrera de ingeniería industrial. Todos los que estamos relacionados a estas áreas de ingeniería y nos gusta la ciencia sabemos que la robótica cobra cada día más vigencia y es muy importante como parte de estas carreras para el futuro de nuestro país y de nuestra parte industrial. Ahora estaremos recibiendo algunas preguntas de nuestra audiencia. Now we will begin with questions from our audience. I'm going to start with the first question. I want to ask you, do you have an estimate on the gains in efficiency using robots on construction? For example, for building a house, what is the reduction in cost, time, and labor?
Yes, of course. So when we address, the economics and the value proposition to the construction company, we bring several values. It's not only the speed and the quality and the price of the robot. We see it as a package, because of course we solve the inefficiency of this industry. There is a very big shortage of labor in construction. We see in countries like Japan, when the workers are very old and they don't have the next generation. And I think that you yourself as candidates for being engineers yourself in the near future, you don't want to work in construction sites where it's all dirty and very low tech. So this industry needs to be shifted into much more sophisticated. So when we bring robots to the industry, we also improve the quality, the monitoring, the ability to predict how much material you will use, how much time you will spend in the construction site. So when a construction company has to bid for a big contract, for example, then you can assess these numbers. We improve, of course, safety. When we reach heights that you don't need you don't need ladders, you don't need scaffolds, and so on. So of course we're solving a lot of problems, and when time comes, we'll be able to, of course, convert this into revenues and provide the industry with something that is very valuable.
Thank you, Nadav. Jose Duron, one of our students, is asking, what are the features of the all new generation of robots? For example, robots used by BMW assembly line in China.
Yes, so I'm not sure if I understand correctly the question, but the big difference between robots that are working in factories and robots that are working in job site or in other areas, it's a big difference, because robots that painting cars, for example, they're mounted to the ground, and they're not mobile. They're just set to a specific program. So they are pre-programmed. While our robots, when they're addressing all sort of job sites, they are facing new challenges, and every day it's a new it's a new area. Sometimes, if even when you come to the job site the next day, you suddenly see a column in the middle of the room, which was not yesterday. So this creates a very different challenges in terms of the work profile.
Yes, I understand. It's a totally different environment. One's with humans and it's a construction site, and the other one is a factory with very limited areas, and the use of robots on factories is a lot easier. It's a big challenge to use robots on construction sites with a lot of people and a changing environment all the time.
Exactly.
Thank you. We have another question. This one comes from Victoria Jerez. She's a student from our career in mechanical engineer. She wants to know what technologies can be implemented in our career in mechanical engineer, which exist in automotive industries. What do you think about this? Which technology can be implemented from the automobile industry into the mechanical engineering?
Okay, so I can tell you that, for example, in our team, we're constantly looking for mechanical engineers that will help us in the design of the robot. And one of our engineers actually is coming from the automotive industry. He used to design racing cars. So we see a lot of potential in the knowledge that comes from the automotive industry that shift to the construction industry. So I think that there are a lot of potential for mechanical engineers in the automotive industry, of course in the robotic industry, and of course in the robotics for construction industry.
Thank you, Nadab. Nadab, we have another question. This one comes from Juan Mantilla. He wants to know if you can see a future on the implementation of this technology, not by multi-billionaire business, not by big enterprises, but instead by small enterprises that construct simple houses for people. Not for big buildings, but for small houses. Do you think there is a future on these kind of jobs?
Yes, so definitely there is. I think but it's not specifically for small houses or for renovation or painting your apartment, your student apartment. We are mostly designating our robot to actually for big projects. Sometimes you need 20 or 30 or sometimes 100 workers at the same time, and it's very hard to get them, and robot can work very, very fast and account for 3, 4 or 5 people sometimes, depending on the work. But the thing is that we see approaches to us, to OKIBI, from all sorts of company and from all sorts of area, big companies and small companies, and they're all sharing the same challenge. They don't have enough workers, and they're looking for solutions to improve efficiency and to reduce cost. So I think with creative business models and with when we will be able to offer not very expensive robots, I think we will be able to offer the robots also to small projects and even to small construction companies.
Thank you. We have another question. This one comes from Matias Aguilar. This one might be hard for you because it's about Ecuador. He wants to know, how much do you think will cost to implement this technology in Ecuador?
Actually, 20 years ago, I spent 2 months in Ecuador in a trip, and I really enjoyed the staying over there. So I really don't know exactly, the cost in Ecuador. I remember the cost of living in Ecuador is not that high. So probably the salaries are not very high. So I guess that in the construction industry, it's workers are paid not very much over there. But having said that, I think it's also a problem in Ecuador and in other regions to address big projects usually. So I think in big projects, this technology can be implemented, and I think we already been approached by several companies from South America, like from Chile, from Peru, from Ecuador, and of course from Brazil, looking for for automation. So I think also your region will be a very good ground for adopting of automation in this industry. Sometimes you need the first company to be the adopter, the early adopters, and then the rest of the companies will follow. So I'm sure that in Ecuador there are some companies that are willing to adopt this kind of technology.
Yes, you're probably right. And you're right. Also, we have plenty of workforce, and salaries are not very high. So probably it's going to take a little while to adopt this technology here in Ecuador. We have one more question. This one comes from Santiago. He says, in Ecuador, the robotic industry is very limited. What recommendation could you suggest to be able to implement the automation of industrial plants for food processing and floriculture? I'm not sure if you say floriculture. Is to grow flowers.
Okay, so I don't have experience with the flowers, but I do have experience with the industrial application with my previous company that I manage. I must say that in Israel, it's also very limited, the usage of robotics, because it's very conservative, and we don't have very strong industry of production in Israel. So probably it's related to the capacity of production power in your region. So if, for example, you have certain areas with a lot of factories and manufacturing plants, so those are the areas that will probably be available or will be the first adopters of robotic solutions. So of course, the automotive industry and the electronic assembly and other sort of industry are already there for many years by the way. But in recent years, we are witnessing, prices of robotics are getting lower, and we see a lot of new brands. So if in the past we only saw brands from Japan and from Germany that cost a lot of money to handle and very complicated to operate. We see a lot of newcomers from South Korea, from Europe that are more affordable. And in recent years, we also see robots that are collaborative and are very easy to program. So you take few online courses, very straightforward. You can, lead the robot by the nose, just take it and operate the robots, and then robots duplicate what you just taught it. So this will, of course, push this industry forward.
Okay, thank you. We have another question. This one comes from Julio Cardenas. He says, up to date, what is the main and major application of the robots around the world?
So I think that the most common application of robotics are coming from the car industry, from the automotive. The witnesses for that is that, a lot of the car manufacturers
purchased robotic companies or developed their own. It's common in Italy, in South Korea, for example. Hyundai have their own robotic brand. In Italy, there's a company called Comau that were purchased by the Fiat corporation. So basically, this is the leading industry because it's a lot of technology over there that requires robotic operation, whether it's for the assembly, for painting, for quality assurance, and so forth. So I think that the automotive industry is leading by far in robotics.
Yeah, I also agree with that. They are probably leading this industry.
Yeah.
We have another question. Juan Diego Mantilla want to ask, he says, robots could improve efficiency and safety, but they could cut cost on constructions.
Yes, of course, because there are two main expenses in construction when building. One is the labor, and the second one is materials. So of course, I think we cut labor. This is very straightforward. The robot works faster. Sometimes the robot can work in two shifts. The robot does not sick. It doesn't take a day off. So this is, of course, helps the robot to be more efficient. But in the material side, we also can save materials, because sometimes when people spray with a spraying machine, it doesn't work very accurately. Just move with his hand, like with his arm like this, and the material sprayed on the wall, and then it comes and level it and do rework. But with the robot, we keep constant distance from the wall, the constant angle, and every time a constant distance from the wall. So every time you get a very even layer on the wall. So the material usage is very smart. And you can predict the material, you can cut waste, and I think this saves a lot of money to the contractor.
Thank you. We have one more question. This one comes from Kevin Fino. He want to ask, what could be the worst scenario of bringing autonomous robots to the construction industry?
Yeah, so I think the worst thing that can happen to all of us is, of course, injuries. A robot that hits some of the workers on site and make damage. This will, of course, beside the damage to the person and the injury, can slow down the penetration of robots to the industry, and make people ask questions and think that it's not that appealing to have robots on site. But I like this question because we of course address this issue with a lot of safety applications. We're using sensors that detect a movement around the robot, all sort of lidars that can prevent, can have like a safety zone around the robot. We have, of course, emergency buttons and all sort of safety measures that are taken in order to avoid this sort of things. This is very important in the site, of course.
Okay. Thank you, Nadav. I have one more question. This one comes from my part. I know that you are not an expert on this area, but I want to know your opinion. What do you think about autonomous cars? How long do you think it's going to take us to have a level 4 or level 5 autonomous car?
Actually, I also interested in this topic myself, and I following all sort of publication in this field. I think that we are very close to a breakthrough towards level 4. We just recently heard about a collaboration of an Israeli startup company and BMW to launch something in 2023, I guess. So in about 2 or 3 years, I guess that we will see cars driving by themselves, with the man just sitting, close to the wheel, not operating the car. So I think it's we crossed the big challenges, and now it's getting closer. Of course, with Tesla and other cars that are already working in the sites, and there's a big leap that's been done in recent years in this area. And by the way, I think some of the benefits that we got in OKIBI are thanks to this industry, because the car industry, with the automotive, with the race for the autonomous car, made a lot of sensor become more cheaper, more available, more easy to handle. This push a lot of additional industry forward, like the construction industry, for example.
Thank you. That sounds great for me. It will be an awesome breakthrough for humanity.
Yeah,
and
definitely.
It will be safer and cheaper, and well, I think everything is going to be better. Okay, I think those are all the questions for today. I once again want to thank you, Nadav, for your wonderful presentation. And
thank you.
I love this topic. I think it's the future of the world and humanity, and it's going to bring a lot of good things for us. I want to thank you a lot, and I want to thank all the audience for being here.
Thank you. Muchas gracias. Chao.
En los momentos de crisis, tu educación es una oportunidad para crecer, para brillar y superarte ante la adversidad. En la UISEK somos tu segundo hogar y mantenemos la excelencia académica como la bandera que nos caracteriza, con un ambiente cálido y humano pensando en ti. Permanezcamos unidos y seamos fuertes en el camino. Cuenta con nosotros para mejorar tu futuro. Universidad Internacional SEC, personalización en serio.